Yes. Okay, awesome. Okay, so the morning session kind of kicked off with a discussion about buzzwords and hype, and was kind of surprised that the big data, the buzzword was not there. So I'll kick off the afternoon session with another buzzword, combining it with our, FHIR. So what I'm going to talk about is like, I'm going to give a little overview of what is big data to trying to separate the hype from the reality. This is probably going to be the shortest crash course on big data, but trying to combine it is like, what are the use case scenarios with healthcare? Obviously connecting it where it meets with FHIR. And then, I'm going to share basically a solution that I actually presented at the last FHIR Roundtable, how we have implemented, MIPS and quality reporting based on FHIR. But then we have extended that solution to use big data and kind of discuss it like, the lessons learned as we implemented it. This is more about that, the architecture, what can be used for any big data solution, but taking quality reporting, as an example of it. Okay, so what's big data? I have to have a slide definition, but there are really two key terms that we need to understand from a concept perspective. When we are talking big data, we are talking like lots and lots of data. I mean, lots, how lot? It's something where, you cannot use that data by conventional technologies to get some meaningful results. And we kind of put it into two words. It's like, okay, the latency in getting those results has to be something that is meaningful. And then the technology to actually reduce that latency is basically different when it comes to big data solutions. So we're going to try to just break these two things, really non-technical, simplify them. What does it really mean? So here is a simple, flow. Like, let's say we have some data, like a large amount of data, but that's like organized data from an EHR, from any system, and so. And you bring that data into a batch processing application or so, and then a user is basically sitting and running queries on that system. So, the user is perceiving the latency as, as the real time of the queries that are happening in there, but that has basically been, improved because of pre-processing of that data or so. So this is one of the, the older kind of implementations, or we can say like, sometimes, this can still be managed with some technologies, but then there's a second, part of it which really kind of, becomes in there. If you can use that batch, that large sets amount of data, turn it into some kind of machine learning models, art AI, all those things, and then make them available to an app. It can be an EHR app, it can be any other app, but it is available to that app in a real-time environment. So, a simple example of that is like, if you go to buy something on Amazon, you're selecting a product and, it is showing you the alert that people who bought this product also bought this. So that's basically big data being used in real time. Based on the product that I'm selecting, it is telling me what, but the data that is actually telling it what to recommend is based on the analysis of that data that has been done before. Applying the same thing to, the healthcare. So the real application of the big data becomes is when you have enough models where at the point of care, when a provider is picking up a particular diagnosis and a combination of a medication, or a biller is picking up a code, you can actually use that data, use that mine data to provide real-time results. So that's like, again, when we talk big data, we have to understand, okay, that's data that cannot be processed in real time, but the value of that data is not that way. It is how it is actually used in real time, and we'll discuss another case later where even that, real-time scenario can differ. So the second part of that is, what is distributed computing? So that's basically, again, before the big data technologies became common, and so the most common way when you have large data or the data is growing is what you do is you basically buy a bigger server and the server keeps growing, and that's kind of the concept of supercomputers or other things. So when we talk about big data, that's not what we do. So the idea there is that instead of actually buying getting bigger and bigger servers, the technologies that are supporting big data are done in a way where the load, both from a data perspective as well as a processing perspective, is spread over basically multiple servers. And again, keeping it really simple, the idea there is that, this is not like, what someone from a relational world would say, okay, we could shard the data or can distribute the data. We are talking of concepts or technologies that are built from ground up to support distributing computing. And one of the core concepts in there is basically what is called as column-oriented database. So some people must have heard like the NoSQL. I mean, they're kind of used interchangeably or not. So I'm going to just stick with this, as an example here. But what you're looking at here is like, let's just say these are three, different FHIR resources. So we are using some common example. But let's just say we have an encounters table, a condition table, and a patient table. And like the data is being stored as, rows in different columns in there. What the column-oriented database basically does is it takes that format and flips it around in the way it is physically stored. So instead of the columns being stored this way in the server or in the back end, they are being stored in a way in a vertical way where there is a unique identifier or a partition key, or there are different terms we can use in there, and then there is a property name along with the value of the property. An important part to understand here is that value is not like a string. It can be anything. So, in case of a diagnosis, if we are comparing it with a FHIR resource, it could be a codable concept. It could be any custom user types or so you do. But the basic concept there is that, you are storing it as what is called as a column-oriented database. So why would you do that? I mean, what is, really the advantage here? And what column-oriented database really gives you is, you basically decouple, the schema versus the actual data that you are trying to store. So the simple way to understand is like we talked about the FHIR is already, FHIR 4 version is coming up, and we'll see an example later. As you start to store the data, you don't have to worry about that. We might have to add new columns later. The actual definition of the schema can be left or can grow over time as the requirements change. And the second part of it, again, some people, when you're coming from a relational or traditional database, world, you will try to compare it to say, okay, I have these rows, and I have an encounter that has 5 properties, and the second encounter has 10 properties. I mean, we have all these, all that I'm losing is basically the 5 space for 5 columns. So it's a lot more than that, because when we are talking the scale of data that we are talking, those empty rows really add up. So the basic idea here is that, we have basically one of the technologies that allows you to store the data in a column-oriented database. Now, once we say, okay, we have column-oriented database, there are again always multiple, ways to do it. These two are the common ones. So, HBase, most of the people that have worked with big data also must have heard the word Hadoop. So Hadoop is an ecosystem under which HBase is basically the database store. How many people have heard of Cassandra? Anyone? Okay, wow. Anyone working with Cassandra? Yeah, that's. So when we basically started converting, our solution, we chose Cassandra, and there are multiple reasons for it from a FHIR perspective. But for starter, honestly, I thought that for once we have a database name that doesn't have a geeky name. I can say I love Cassandra and my wife is still not upset over it. So, it just feels like, okay, but the real part of the real, value of Cassandra versus the other databases and so is actually in that I logo. And I mean it literally. What that means is if you look at it carefully, and it is probably not clear in here, that I has a circle in there and that circle has a meaning. So what Cassandra does is, it is one of the, the most common kind of the big data technology that supports a decentralized architecture. Now, let's just make sure I'm talking decentralized, which is different from distributed. So distributed is where we said that we load it across multiple servers. What Cassandra allows you to do is typically in like a Hadoop ecosystem or so, when you're using those big data technologies, you have a single point of failure. You have multiple clusters in the back end, but there is still kind of one master or a slave node, that can do it. So Cassandra has this, the decentralized architecture that is, kind of the I in there, that allows you to, especially if you're using it at point of care, to use it in, ways where it supports it. There are some other features in there, from a FHIR perspective. It has a strong JSON support. The indexes, it's pretty forgiving from a big data technology perspective, and the query language and so are, pretty good. So by the way, this is not something new. So, if you haven't heard of Cassandra, these are all the companies. The Netflix is the one of the, the big ones. They have a dedicated blog where they talk all about the big data, how they use it and so, and it's pretty, amazing. And Apple is another one that is a big, that have advertised about how they use actually, Cassandra. So, okay, so that's theory. So let's just try to see how do we, kind of take those basics, those real concepts, combine it with FHIR and try to convert it into a solution, that we can basically implement. So as we started the process of, taking an existing FHIR solution and we were saying, okay, we want to do big, we want to do the big data, solution in there. So there were three things that we had to kind of, go through. So obviously the first is that we have to choose a solution for distributing computing. So, we kind of chose Cassandra and, the technical. And the second two, the other 2 points was that we wanted to leverage the FHIR resources. So, don't start the schema and other again, and we were already doing it. But then the main part of it is like, we want to be sure big data solutions are going to span over, a longer time than average FHIR versions. I mean, I heard the 18 months is the average. So we needed to make sure that they basically go, beyond the version. So what we kind of did is in a very simple way is like, if you see this as a FHIR, resource in there, what we, in our backend schema, we are kind of storing the columns, but then adding our metadata over it. And again, this is an oversimplified way of how we are doing it, but it kind of gives you the idea behind the scenes that okay, we are actually using FHIR as a data source, data storage schema, but then adding our properties to it. And what that gives us, like right out of the box without doing much changes or so, we are able to create a model where we are working with multiple vendors or multiple products that are supporting different versions, bringing them to a central spot and being able to spot it, being able to support both our apps or other apps from both sides. So this is actually a full implementation of how we are implementing it. So the actual technology stack where the data comes in there from multiple sources. We have a source where the bulk data, so the bulk processing that we talked about happens there, and then it can go into Cassandra and make it available from there. So okay, so with that we come to the solution. So I'm going to ask a quick hand here. How many people have heard about MIPS here? It's got to be our US friends, right? So MIPS is like, the solution, as I said, we have is, we have actually built a full, MIPS reporting solution that works on FHIR. And the kind of, what we did was, as MIPS was going into place, FHIR was still in, about 2 years was getting started. So we had to come up with a very, simple way of connecting and integrating, data with the EHRs to be able to do MIPS reporting. So we started with a very simple idea to say, let's not try to create a complete FHIR, resources or so. We identified a FHIR, a patient bundle. So an EHR basically can export a patient FHIR bundle. These are the resources that you have identified, and how do we actually know which resources to pick? Again, this can vary on your use case or so, but we kind of went through the US core implementation guide. The QRD and the HQMF are the files that are used for, quality reporting, but they give you the idea of what data do you need. So that was kind of our starting point to say, okay, let us take all the quality measures, go back and understand them, and then use that to implement a full quality reporting system. So I can't go into the details. We obviously don't have the time, but I'll just leave that URL there. This is actually the last presentation that we have done where we have talked in detail about how we take a resource, we broke it into there, and we made sure that we can actually, implement a whole FHIR solution, from it. So this is, again, we talk with a FHIR-based quality reporting system and we say, okay, we move it to, big data. So, by the way, this is the application. So this is the plug and play EHR application that can be used by any EHR supporting FHIR or, embedding FHIR sources in air in their solution to connect to it. So that's basically, as we said, is like, okay, how do we use FHIR, big data at a high, at a high level in there. But then there's one more thing, kind of why when we started this, the whole idea about, we have an app that works on FHIR. Why do we need big data? What is the real, use case, and kind of, we went back in there. So right now, the use case that we are talking about, pretty much fits in there. And, it's going to take a time to actually, create those machine models and so. But the reason kind of, to going big data is, that there is another, kind of leg of this that you can say that works in there. And that's like once you start using those big data technologies like Cassandra and so, you are not limited by that real-time processing being compared only with batch. So it brings in a concept of what is called as streaming analytics. And what that is, that you actually now, based on those distributed technologies, and so you can actually analyze the data that is coming in real time. And again, a simple way to see this is detecting an outbreak. So if you have connected it with patient apps, all the apps that we are seeing here, but somehow those apps are connecting or feeding some part of data to a central system, and you have a big data solution that is collecting that data, it gives you it enables you to do real-time analytics. And that's again, enabled by a solution by, again, an open source project called Apache Spark. So the idea of moving from an existing FHIR to, a big data FHIR to support is not just to, use the buzzword or so, but it is also to make sure that, we can kind of grow towards and make a use case where we can support, other technologies. So I got my 1 minute warning, so I'm going to leave with my FHIR pun joke. So, you say they can't start a fire, so I'll just say you can't start a big FHIR with the Apache Spark, and hopefully I can present on that one in my next summit. Thank you.